Myself Sumuka. I'm a student from SPC, currently studying in the third sem of engineering. Today's topic is simple file system with shell commands and memory management. This project is done by Sumuka S, Shashi Chandrasekhar, Rakshit Yu, and Yashwant Gowda. Introduction. The purpose of this project is to design and implement a simple file system, the C program language. At its core, this project aims to replicate essential functionalities of file systems commonly found in modern operation systems. By developing a simple yet functional model, users gain a practical understanding of how data is organized, stored, and accessed in computing environments. This project facilitates file and directory management operations such as creating directories, entering files, listing contents, navigating directories, and deleting files. These functionalities from the foundation of any file system, making this project an excellent starting point for exploring their underlying principles. By simulating these operations, users can observe and learn how hierarchical files organization works in practice. To enhance realism and the utilization of the project includes a memory management model that simulates block-based storage allocation. This feature replicates how operation systems allocated and deallocate memory for files, ensuring sufficient storage usage while addressing common challenges like framework and such as approach bridges the gap between the abstract theoretical concept and their practical application. Overall, the project serves as both an educational tool and a stepstone for further exploration of advanced topics in file systems and operating systems. By integrating key concepts of file and memory management, it provides users with an engaging and comprehensive learning experience, highlighting the importance of these systems in everyday computing. Scope. This project serves as a functional framework for understanding the principles of file systems and memory management. By simulating real-world file system operations, it enables users to explore concepts such as hierarchical data organization, memory allocation, and error handling. This project's scopes include the creation of a tree-like structure for directories and files, mirroring the design of modern operating system. Simulating memory management through block-based allocation offers insights into physical memory usage and common challenges like framework. This approach is tailored to provide a accessible yet comprehensive experience for students and enthusiasts. The scope also encompasses a user-friendly command line interface with robust error handling capabilities. It allows users to experiment with basic file system operations, enhancing their understanding of how data is structured and manipulated. The project sets a strong foundation for exploring advanced topics such as journalism and access control. Key concepts include hierarchical file structures, evaluates real-world data organization with directories and subdirectories, memory management, demonstrates block-based allocation and efficient usage of memory storage. Command interface supports essential operations like creating, deleting, listing files, and directories. Error handling ensures system reliability and user guidance for invalid commands and operations. Modular design encourages further development and experimentation with advanced features. Overview. The implementation of this project consists of the following core concepts: directory and file structures. Data is organized hierarchically, resembling structures. Each directory can store files or other subdirectories, reflecting world organizational methods. This structure simplifies data revelation and management. Shell-like commands. Users interact with the system using commands such as a make directory, which is used to create a directory, a cd, which is change directory, is, which is used for list contents, touch to create the file, rm to remove the file or the directory itself. These commands make the system intuitive and user friendly. Memory management. The file system uh, simulates block-based storage allocation, which ensures efficient memory allocation.
One, I'm here to explain the literature review characteristics. Simple file system manages files and directories, especially typically using a tree structure. Shell commands allows user to interact via command line interface to perform operations like create, delete, read, and write. Memory management, efficient handling of memory allocation and deallocation using techniques like linked list or bitmaps. Benefits, user control. User have direct control over file operation through shell commands efficiently, simply. Algorithms ensure faster and efficient execution of file and memory operation. Educational value helps in understanding low-level file system and memory management concepts. Advantages and disadvantages. Flexibility, easy to modify and extend according to specific needs. Transparency, clear view of how file operations and memory managements are held. Resource management, effectively management of system resources like CPU and memory. Disadvantages, scalability may not handle large number of files or complex memory management efficiently. Security, basic file system might lack advanced security features. Error handling, less robust. Error handling compared to more uh, sophisticated file system. Simple file system and shell commands. Structured definitions define structure for files and dictionaries. File system functions. Implementation functions for creating, deleting, reading, and writing files. Shell commands, implementing basic shell commands to interact with the file system. Memory management, implement memory allocation and deallocation. How it works. File structures define the structure of the strong file name and content. File system structure manages the array of files and keeps track of the file count. File operation functions to creating, deleting, writing, and reading the file. Simple shell allows users to interact with the file system using the commands like create, delete, write, read, and exit. Thank you. I'm handing over the speech to the next person.
Hey guys, I'm gonna explain about the implementation of this program. This program simulates a file system with directories and files where you can create directories, change directories, create files, delete files, and list the contents of the current directory. It uses an in-memory structure to represent the file system with a block-based allocation for files. Here's a quick breakdown of the key components of the program. There's a program and next is data structure directory. So holds files and subdirectories. Each directory has a file count and sub directory count to track the number of files and directories respectively. It contains an array of files and subdirectories, pointers to directory file. Each file has a name, size, and start block, which points to the memory block where the file starts. Memory simulation. Memory is simulated as an array of blocks with each block having a fixed size. Block size is equal to 512 bytes. So the total memory size is 1 MB. That is memory size. So the key functions are mkdir, which is it creates a new directory inside the current directory if it doesn't already exist. CD, that is it changes the current directory. If is passed, it moves to the parent directory. Is it lists the contents, the that is file and directories of the current directory. Touch, it creates a new file in the current directory with a specified size. RM is used to remove a file from the current directory, freeing up the memory blocks it occupied. Next, so memory management, allocate memory. So the memory management allocates memory blocks for a file that it checks if enough memory is available or not. So deallocate memory. So frees up the memory blocks occupied by a deleted file. So the main command loop. The main function simulates a shell where the user can input commands like mkdir and dir.name. So creates a new directory. cd uh, brackets dir.name and that changes the to the specified directory. Is lists the contents of the current directory. Touch file name and size. Creates a new file with the specified size. RM. RM is used to delete a file. Exit is used to exit the set. So this is the uh, next is consideration. So consideration is error handling. That is, the program includes basic error handling such as checking if a file or directory already exists or if there's enough memory for a new file. Memory deallocation. Memory is freed up when a file is removed, but the actual blocks are not used for the other files. In this simulation, memory limit. The simulation has a fixed memory size of 1 MB, so users cannot create files larger than the available memory. So the potential improvements are better memory management, that is implementing block reuse or freeing up memory blocks more efficiently could optimize the use of the available memory. Dynamic allocation, that is the program currently allocates a fixed amount of memory at the start in a real system. Memory could be allocated dynamically, that is file or directory navigation. Additional commands like pwd, that is print a working directory, could enhance the user navigation. Next is challenges, outcomes and results. Explanation of the output. So creating a directory, the command mkdir documents creates a document directly in root, which no output upon success. That is changing directory. The command cd document switches the current working directory documents. Creating files. Touch file.txt and it creates a file named file1.txt of size 100 bytes in documents. Similarly, touch file2.txt 200 creates another file of 200 bytes. Next, listing files. This lists the files and subdirectories in the current directory showing file1.txt and file2.txt. Removing files. The rm file1.txt deletes file1.txt and it shows the updated list of files. An error is shown when trying to remove a non-existent file. Exiting the shell. The program ends when exit is done. So this is the example for the outcome. So this is the current outcome.
Now we will discuss about the literature review. Characteristics. Simple file system. Manage files and directories. Typical using a tree structure. Shell commands allows user interaction via command line interface to perform operations like create, delete, read, and write. Memory management. Efficient handling of memory allocation and deallocation using techniques like linked lists or bitmaps. Benefits: user control: users have direct control over file operations through shell commands. Efficiency: simple algorithms ensure fast and efficient execution of file and memory operations. Educational value: helps in understanding low-level file and memory management concepts. Advantages and disadvantages. Advantages: flexibility: easy to modify and extend according to specific needs. Transpa Transparency: clear view of how file operations and memory management are handled. Resource management: effective management of system resources like CPU and memory. Disadvantages: scalability: may not handle large numbers of files or complex memory management efficiently. Security: basic file systems might lack advanced security features. Error handling: less robust error handling compared to more sophisticated file systems. Simple file system and shell commands. Structure definitions: define structure for files and directories. File system functions: implement function for creating, deleting, reading, and writing files. Shell commands: implement basic shell commands to interact with the file system. Memory management: implement memory allocation and deallocation. How it works: file structure defines the structure for storing file names and contents. File system structure manages an array of files and keeps track of the file count. File operation functions of creating, deleting, writing, and reading files. Simple shell allow user to interact with the file